Hello everybody and welcome to my speech. So I'm Anton Dorfman from Mitsubishi from Positive Technologies, and we will talk about how to hack PLC without any access to firmware. So let's start. The first, I will give you a short information about me. So I'm a researcher, and I'm like some kind of automating reverse engineering tasks. Also, I'm found some CVs in industrial systems and spoke at some security conferences. And as you hear, that I had a lot of experience in reverse engineering. And let's talk about the agenda. In first part, we will modeling some first steps of the researcher together. After this, we will talk about stages of the research. Something happened. And after this, I will discuss the results. And of course, we will talk about a bunch of vulnerabilities. Okay. 1 second. Sorry. Power. Sorry for the technical issues. And after this, I will show some demo, and it will finish. It will be finished. So, I got such PLC. It's called Mitsubishi FX5U. You can see it's, the front panel of it. And there are some indicators. And you can get what is happening with this PLC. And we have some free research goals. One of them is analyze and describe the protocol. Second, write scripts to communicate with it. And third, find some vulnerabilities. So let's model the first steps of the researcher. And welcome to my world of bytes and bits. So I got this traffic sample from my teammates. And what you see here, just take a few seconds to try, to structurize it a bit. So I see some fixed bytes at the beginning and some type of magic. Also, I see 3 bytes, FF03 on the first line of the answers and questions. And on the right side, you can see, the model name. So I analyzed a dozen of packets like this and made some structure of this protocol, some first variant of structure. And I marked some fields, and you can see these fixed values at the beginning and some other fixed values. And also you can see the field data size. And of course, there is some end code and existing only in the answers. And we jokingly called this type of analysis reverse Eye-Gineering. And so we got the structure of the protocol, and we decided to look the description for it. And the web didn't help us, the internet. But my teammates visited some speech just before the project. And inside this work, guys talking about M protocol. And this is its structure. We can see fixed value at the beginning, some data size, and end code. So let's us dig deeper. Maybe it's our protocol. And we decided to compare it with the our traffic. And you can see that first bytes fixed matched, but they has a little difference between them. And also FFF03 you can see in the both cases, but the command code 0304 we didn't find in the traffic. So it's not our case, not our protocol. Let's see in the manuals. Mitsubishi manuals propose information about two protocols. It's called MC protocol and SLMP. And you can see a short description of them in the left, and on the right, some, expanded description. And let's compare. Here we also have some fixed bytes, some of them matched, but command code for the command device read random is not presented in the traffic. So it's also not our protocol. And we decided to compare this protocol with this work from the conference. And let's compare them. And you can say that they are matched. So that M protocol, just the protocol from the manuals. And we found some interesting field. It's called device code. You can see in the bottom. And it has, the value A8. Just try to remember it. So at that moment we have some first results. And on the top you can see the open ports for this protocol. And I wrote some first scripts to communicate with PLC via this protocol. And at that time, pandemic hit and everybody went remote. And I haven't my access to PLC configured, and I just sent the scripts to my teammate who had this PLC at hand, and he just tried to run them, and this is his answer. But it's in Russian, it's original email from him, but it's about success, that scripts work without any previous testing. So it's good. And we went on with the research. So now we will talk about research stages. And at the first moment we faced with some problems. Firmware updates. You can download them from the site, but they are encrypted. And our applied cryptography expert, he tried to unencrypt them, but try to find which algorithms are used there. And his decision was that we should, extract the firmware to find the keys or just get the firmware. And our hardware guy, he did a lot of work. First of all, he dumped the external flash, and we didn't find anything inside it. And after this, he tried to extract the internal CPU flash, but it failed. And so we didn't get the firmware, but I decided to continue the research anyway. And what can be helpful in this case? It was the first case that I met in my, in my work, in my practice and experience. What can we get? What sources of information can we use in that case? First of all, the well-known rule, it's called read the following manuals. And as you can see, everybody knows about it, but nobody follows. First of all, I read the manuals, and what can we get from them? It's some common description of the device and its features. So we can see some security update, and we can know that it has some own file system. And there are, three main features, main moments. First, it's the commands that we are dealing with before. Second, devices. It's some kind, it's some inputs, outputs, some, internal, some relays, some timers, and remember that device code A8. You can see it, it's data register, so we can try to identify this device, but not for our protocol, but for the similar protocol. And also, one of the interesting feature was that all settings are loaded to the PLC as files. So we can try to research these files. And the next, the next piece of information we can get from the software. And there is some tool, GXWorks free. It's some, development environment and engineering software all in one. And it has some standard features and, interface. You can see it on the right. And what can we get from this software? We can identify commands, devices, and can find the settings inside the files. And the most interesting thing inside this software, inside this GXWorks free, was the simulator. The simulator is emulating the project files, the PLC project files on the PC. And it has some features. It's a local host only connection, uses only TCP, and you can set up the port. And the protocol inside it looks similar to PLC. And we decided to dig it more. And I used well-known Process Explorer to find the binary and the command line. Inside the binary, I have some external links to DLL, FX5U, and inside it I found some, model name. And also I learned how to run it without this GXWorks system. So, after this, I decided to brute force commands, and I I run this brute force on the PLC, on the simulator, just to compare and to understand the things. And you can see that the simulator, it's pretty good in command realization. Let's look inside. We can see command types for different parts of system. For example, for simulator, we have some number of them, and 11 of them is just stop functions. Sorry. And in the manual, we have some description not for these commands, but for commands of the similar protocol. And we decided to compare them, and you can see that marked in blue commands are matched, but marked in red, they are similar, have some, have some patterns. After this, I decided to brute force devices, and they have the same number on the PLC and on the simulator. And I also decided to look inside, and we have 20 devices in the manual. You can see all of them in the top. And again, this data register, 8. And the simulator has more devices, 32, and we see it's possibly that 12 of them are unknown devices, maybe some secret devices. But if we see the numbers of devices, we can't, can't get any matches between them. So, and main thing that the emulator is pretty good in emulating the PLC, the real PLC. So now the short information about reverse engineering the simulator. First of all, it has, we faced also with some problems, and we have no hints inside this DLL in debug symbols or text strings. And what can help in this case? First of all results we've got previous. And the second, this principle or rule, RTFM, we can use it. And the coolest thing, was that we can research the simulator with a debugger. It's some kind of cherry on the cake. One moment. So during this part, I will discuss some cases. Not, of course, not the whole work of reverse engineering, but some cases, interesting. So, how continue? So, the first case, how can we use this similar protocol documentation? I found two handlers inside the code. You can see them on the left top. And one of the handler, one of the, type of protocol have the handlers of particular commands. And you can see it on the right top. So I marked the one command. It's type 2 CMD for free. And it's actually device read random. And this handler calls some function with stub, with some dump name. And if we look through the cross-reference to that function, we can find that the command from another type of protocol also calls it. So for our protocol, the device read random is 0411. In this way, we just identified all commands inside the simulator. And after this, is one more case, how some error codes helps. We can see in the top some code and some variable compared with EAX register, and if it's less or equal, it jumps to some label. And we can see that some error code for 1.3a just copied to end code. We go to the documentation, and we know that it's some kind of file size. So we identified some variable. And one more. During the research, I found some interesting numbers. I matched the 166000000, and after him, you can see some call of the procedure, which map it to real address. And I wrote some bunch of scripts to analyze, to group such offsets, and analyzing the code, I understand that this is the offset of the input device. So I can now research how the simulator communicate with this input device. And during debugging, there was one issue that when I tried to load this DLL into the debugger, it's do some image rebase. And during this image rebase, all offsets I found before, they goes bad. And I have two versions of iDebase, one for the main research and second for the debug issues, and write scripts to transfer results between this iDebase. So let's talk about results of our research. First of all, of course, we have a protocol description. This is some type of high-level structure of it, and you can see these fields that we met before, and I get my teammates made some Wireshark dissector for this protocol. Now you can see these fields, but more friendly for the people. And also I identified the most of the commands and devices. You can see some of them in these tables, and we can see this read random command and data register. They are marked in color. And on the left side of the tables is the numbers for our protocol, and on the right is the numbers for the similar protocol in the manual. And also I created some, script system, a huge script system, and it has each command in it of PLC is implemented in own module, and we have some abstraction layers that hide realization from these models, and such type of structure can be easily give you easy programming of high-level functions like reading the file or brute forcing some command. And you can think that documentation it's boring, But I want to show you the opposite. There was such, TV show, Knight Rider, and inside it, the main character has the car, the smart car. It's called KITT. And in the top of panel, in the front panel of this car, there was some lighters, and they moving like a snake from one side to another. And we decided to model this on the PLC outputs. And let's start the demo. You can see that the speed of our Mitsubishi and of the KITT is a little bit different, but with knowledge of protocol structure and the commands, you can just manipulate the PLC outputs and do whatever you want. And the next part is about the vulnerabilities. We found 15 of them, of vulnerabilities, and some, timeline. First we sent report, and during the week Mitsubishi answered to us, and within a month they sent us some advisory plan, and let's see at the first bunch, it's PLC bugs, and they affected not only to FX5U, but the whole series inside Mitsubishi products, inside their PLC. And the two of them are in the bottom are the denial of service bugs. And also we got the 7 bugs in this software, Jigsaws free. They also can affect different PLCs on different series, and also not only Jigsaws can be affected by them, but other tools. And we can see that they have some hard-coded crypto keys or hard-coded passwords. It means that they are all about security functions. So let's consider security functions. They're simple. On the PC side, there is block password and security key. On the PLC side, there are 4: security key, file password, remote password, and IP filter. And the first bug, it's about file password. When we can get the hash from free sources, you can see it in the left, from free commons, and we can use it hash to bypass these security features, file password. Just send the hash. That's all. And the next, the bug also about file password, and it's the cool thing about RTFM rule. We just get it from the manual. It means that there is some file for remote password, and it's not protected by file password. So we can just write our own remote password, and somebody will not get access to the PLC. And this remote password is very simple idea. Before starting to work with PLC, you just should unlock it. And after work, you should lock it again. And we have found also bugs in this remote password. First one, the similar hash instead remote password. We can just send the hash, and PLC will be unlocked for us. And we can get this hash from free sources. One of them is a project file, and from the command, you can see it in the left. And I give that hashes and passwords to our cryptography guy, and he just use a few pairs to understand the protocol, to understand the algorithm, and to make some transformation from hash to password. And you can see the script in the bottom, and you can see the remote password for that hash. And I found that hash also stored in some file, and it's organized in 4 byte chunks. And in this file, I can also find the password itself. So the next one is it's about security key. There are 2 sides, 2 options. On the PC side, it's protect the access to program files, and on PLC, it's just not give you execution if you have a wrong key. We researched its internals, and only thing that user can set is security key name. After this, auth code, and everything else is generated. And after this, we can get auth code. From auth code, we can get security key value and the Ethernet key. These 3 secrets are the basis of security key. And we found a lot of bugs inside this mechanism. First, we just can capture the command, write security key, and just replay it. That's simple. And security key, also some secrets of it have clear tick storage. One of them in the top in the PLC, and which in the bottom in the program file inside PC. So that's also pretty simple. And these 2 bugs is concerning to this transformation between auth code to security key value and between auth code to Ethernet key. And on the right you can see the scripts that just get one secret from another. And there is some, key distribution. You can export the key and somebody can import it. And this file of key is protected by import password. Okay. So another RTFM, another using of RTFM rule, we found some file of keys and it has hard-coded import password. So we just input the password and get all keys of it. And also some cryptography keys in this procedure was we found them, and in the script below we can see the extracted import password. Also, they are stored in project, and we can get them from the project, some secrets of security key. So, let's start the last part. It's about 2 bugs and demo. The first bug is integer overflow. We have some function, and when we try to write or read from device, this function have the formula to get the real address from this offset of the device. And on the first point, we just set some device start address and unit size. And on the second, if we set the device offset a big value, we can get real address is equal to 0. And there are two checks of this device offset, and if the real address is 0, so device offset is not checked. And for demonstration, we use the model of oil pumping station. You can see the components in the left. It's the model from our standoff event. And now let's see the demo. Oops, sorry. So here's this pumps. Oh, sorry, it's another. Okay. One moment. So here's the oil pumping station. You can see pumps. And here's the SCADA screen. And here's the PLC. And my teammates run POC script. And everything going bad. There is no connection to PLC. All stopped. And you can see the error on the PLC. It means that it's in some type of bricked state. So the next bug is that out of bound read. The files inside the PLC consist of two parts: the header and file body. And there is some checksum calculation. And if we send some small file with hacker inside, the second 2 bytes will be reviewed as header size. And we get the big file body size, and this checksum calculation will fail. And for the demonstration, we decided to use another station, water intake station. Let's see the demo. We have this station, some pumps, and we have some SCADA screen, and of course our guy, the PLC. And we run the POC scripts. SCADA, sorry. There is no. Only SCADA screen is not good, but PLC is worked and everything is worked. So it's, let's compare this box. First bug was a little bit harder, and the second just turn off the connection. And I made some POC improvements, and now it's break the connection on all ports, and nobody can connect to the PLC. And there are a few paths of attacks which using the bugs that we found. If we have no security, we can just attack with denial of service. If we have remote password, we can bypass it by one of the 2 bugs. And if we have file password, we can bypass it also. And from that moment, we have some research results. So we get the protocol description, we wrote scripts, and found 15 bugs. And what's next? Now I'm researching other series of PLC of Mitsubishi, and I want to thank these guys for helping me. Thank you.